thanks everybody for joining. I think I know most of you. For those that I don't know, my name is Jason. I'm with Atlona. I've been here about 5.5 years. And we have invested heavily in USB and USB-C for the past 5.5 years. And we feel like we lead the market space in this category. We are going to be doing a full training class, which is an Avixa certified class. We do this as webinars nationally and globally. So this is a class that we run probably at least 2-3 times a quarter. So if you guys want to get involved in it outside of this or have other people join it afterwards, you can. Just most of you know me. If you don't, I'll give you my email address. Hit me up on email and we will put you in our database and we will send you invites for when these classes are taking place. About 30-40 days ago, we announced the first ever multi-port USB 3.0 or 3.2 version 1 extender products. So when I mean multi-port, multi-hub ports, so 4 ports on the hub side, single host on the host side, but we're also going to be showing, Don's going to be, while he's teaching, we'll be showing video over the USB data feed, and we'll also be showing Ethernet injection in that, and also, we're not. And then, okay, sorry. And then also video. So it's a very unique solution. It is very cool. We're the first ones to have something like this on the market. He's also going to show you the integrated user interface into the product. So there's a major value add. For those of you that hit integrated USB, a lot of people are struggling with either enumeration problems or putting too many ports into the design and all that other good stuff. So Don's going to talk about all the important things about designing rooms with USB, but we're also going to be showing you again state-of-the-art products. So it is shipping, and we're going to show one thing that is not quite shipping, but it's going to be also unique to us. Again, state-of-the-art, really put you guys at the forefront of having to extend over CAT and get the full 3.2 capabilities of USB. So without further ado, take it over. Sure. Thanks, dude.
I believe so. It's 1 unit. But cool. All right. Well, my name is Donald Trinh. The title is just the title, but my true title is like the Atlona janitor. I gotta clean up Jason's mess because he's the sales guy. But yeah, other than that, I have a team that I work with that basically helps out with system design. So if you guys ever in need for any type of verification, or like you're putting together a system and you don't know quite all the parts and pieces that we offer, just reach out to Jason, myself, and we'll kind of put together, what the concept that you were thinking, and we'll kind of push you towards the product that we think that will fit best for you guys, right? All right, awesome. So today we're going to talk about USB and USB-C in AV. We're going to, the market trend right now, everyone's shifting over that connector, right? So USB-C is actually just a connector type. It's not a technology that are being used, but obviously all the phones, all the mobile devices, new computers now, slim format, they're all adopting USB-C. So now we have to know how to treat that and what the capability of that machine or that device can actually handle. Yes, sir.
So I have a question already. So
yeah.
When would you say you started to see this shift of actual, like, yes, the laptop companies have been doing it for a while, but when did you start to see the shift in integrators like adopting it and saying we need to go this way?
So it's not so much of integrators that are taking and kind of adopting. It's more like what manufacturers are actually adopting it and is able to natively support that connector type, right? So we started USB-C, adopting USB-C back in, I think it was like 2019 with our first product. But yeah, so basically the rollout now, every new device that we have now actually has a USB-C natively as an input, right? And that's for video and audio. Obviously with USB-C, it carries a lot more signals than just AV, but I'll go ahead and go through that in a few minutes here. But I'll address any question. Yeah, if you guys have any questions, feel free just to blurt it out, and I'll be able to help you answer it. So we'll also take a look at analyzing USB connections. I have a couple of tools that I'll show you later. Not every USB-C cable is the same, right? Notoriously, this guy comes with a MacBook or Apple device. Charge, data, no problem. Connect this to any type of switcher or any monitors, you're not going to get any video. So we'll talk about that. And then we'll kind of go through and I'll also talk about the different generations of USB, and we'll start out from 1.0 and kind of go from there. So why did we adopt it? During the pandemic, right? That's when we heard the uptick of all the soft codecs and whatnot, right? So then, since we're hosting everything through a soft codec and a laptop, now a lot more stuff needs to be integrated. Before, we could just use the webcam on our camera and the speakers from our laptop, and it was just fine for a single person, right? But when you're in a big group, you need something more. You need some DSP to cover for your audio, right? And then video-wise, you need PTZ cameras, high-end webcams to capture the audience, okay? So with that being said, obviously, we're shifting, similar how the technology for HDMI first rolled out. It used to be DVI for all commercial, right? Because of the locking connector. We'll never go to HDMI because there's no locking connectors. No, we did, right? We ended up, and everybody had to adopt it because everybody that's either a source or a display, they're adopting that technology. So when that came out, we had HDMI high speed. We also had, HDMI with Ethernet, controls, all that. So as the technology evolves, us as a manufacturer, we also have to evolve too. The entire industry has to evolve, right? So when we had the soft codecs come out, now we have HDMI and then also USB for our webcams, right? Audio devices. And then now we're seeing a shift now, like you said, all the devices are now going to USB-C. Now we're gonna have to shift over to USB Type-C connectors, okay? So USB-C Type-C connectors, let me see here. I'll actually go over, why don't I go over this here? So anybody remember this guy? All right, anybody have a guess when the first USB-A connector was adopted, or just USB-A? 1996. Okay, 1996. So USB-A Type A. Okay, so the one on the left is your typical 2.0. The one on the right, obviously, if you look here, there's more pins, right? So then now this is the super speed. Okay, on the other end of that cable typically is the printer side, right? And today we still see a lot of these cables around, and everybody looks at it and it's like, oh, okay, we could just plug it in, no problem. Well, no. Now, if you're working with video, yeah, forget it. If you're obviously printers nowadays, they still have the port. Some actually got rid of it already, and it's all Wi-Fi now, right? And they could self-host, do all your printing wirelessly, or even just sending a file directly to the printer itself. But for USBs, it evolved from little, mobile devices, using USB, mini USB, so StarTAC, right? The Motorola phone started that, okay? And then, they wanted a smaller connector, so we went to the micro USB, and then, who remembers this guy? What was that used for?
3.0.
Huh?
That was 3.0.
3.0, yeah, but what was that used for? What was one of the first product that adopted that? What do you need to transfer the external hard drives? Exactly. So kind of evolved to that, and I don't know. It's just too many different connectors, right? So then when the industry went to USB-C, it saw that it was able to capture every single generation of speeds that, kind of incorporate all in one connector. Okay, so as far as USB 2.0, not all USB 2.0 products are the same, right? They can be USB 2.0, but doesn't mean that they're gonna use the full bandwidth of 2.0, right? So if you're looking at a 2.0, let's just say a camera, typically 2.0 is up to 480 megabits, right? But typically in that scenario, it might not utilize all 480 megabits, right? There needs to be headways for communication between the devices. So it could be 180 megabits, it could be 60. It depends on the resolution and what the camera utilizes. But as we go further on and move on to USB 3.0 devices, there's going to be a lot of different variants with that as well. 3.0 devices can always downside, or I guess downgrade to 2.0 for compatibility's sake, right? Okay, so let's take a look at a couple of different devices here. So these are the basic terms that we use for USB, right? For anything that's a host, it's going to be your computer. Any devices that are going to be utilizing peripherals. I/O devices is going to be your peripherals, cameras, mouse, keyboard. Hubs are very important as well, because in USB, there's only a certain amount of hubs that you can utilize before the entire, or I guess the last couple tiers, you won't be able to enumerate your USB. And then compound devices. Anybody have any idea what compound devices are?
Be a mix of like your I/O and a hub.
Yeah, so like say for instance, you might have a keyboard with a hub in there or a monitor with a hub, right? Those are compound devices. And then composite devices are your video bars, right? That has your audio, video, speaker all built into one. Okay. So as far as the data signal flow, obviously when you're connecting a device to a laptop, first basically ask the device, hey, what are you and what the capabilities are, right? So that's how it does the exchange for enumeration. And then, excuse me. Bless you. Okay, and then as far as the transfer rate, depending on the device, right? So controls, that's just basically it can communicate, or as soon as you connect, it communicates and see what the device is. There's interrupt, which is another type of class of data transfer, like your USB keyboard, mouse, and then depending on the other devices, isochronous and bulk transfers, that can be actually, the camera can actually do either or it selects one of the two transfer method. Isochronous is basically that it needs to use the full bandwidth that it, like say if it's gonna be one of those webcams that are live and you don't want any latency to it, they're gonna be using the constant bit rate of that data transfer. So like say if I had a bandwidth of, let's just say 50 megabits, right? And this is an isochronous device, it's gonna utilize the entire 50 megabits all the time. Either that or then it shuts off. That means there's nothing. Bulk transfers, think of more like a hard drive or a flash drive, right? You're transferring stuff, but if it doesn't have the bandwidth, it'll just slow down, and if it's missing anything, it'll be able to recover. Anything isochronous, either you get it or you lose it. Okay. Okay, well, I was just talking about that here. And then all the PowerPoint stuff, we can probably put in a PDF. You just email us and we'll get it over to you. Okay, so let's take a look at USB layers, right? So some devices have USB 3.0 ports and some USB 2 based on the connector color. That's not always true, but that's what the standards are, right? So anytime you see a blue connector, you know that that's going to be a 3.0 supported device. So one of the products that we have here, if you're looking at this is actually one of our newer products. It's called the SW21TX, and what it does for us is it's going to give us local input, so HDMI, USB-C, but then you also have your local hubs and hosts here for USB 3.0. You notice there's also a HDBaseT output there. Anything that's on the back end of that output, since Valence doesn't support USB 3.0 with any combination for video and USB, that now becomes any device on the receiver is not going to be a USB 2.0 capable transfer. Okay. All right. I mentioned earlier, not all most devices that have USB 3.0 connectors are able to downgrade for compatibility for 2.0. And some actually, you're gonna have to check with manufacturers based on that, but some actually don't. They'll actually keep it in the 3.0 realm, and you won't be able to enumerate if you don't have enough bandwidth, right? Okay, so talk about enumeration. So a device, once a device plugs in, a device meaning one of the peripherals, it's gonna talk to the host. And then from there, it's gonna say, hey, what are you? You know, and then I'm class X. I can do capabilities, this capability, that capability. Okay, we got a whole list. Awesome. So then now it knows what the specs are. It'll start communicating, and then that's how you hear that little ding on your computer, right? As soon as you plug in something, you hear that, well, Windows, what? I can't remember. It's in my head, but you know what I mean. So that's, oh, there you go. All right. All right. And then if enumeration fails, you're not going to hear anything for that. Most of the time, well, let's see, what's a good example of that? Either wrong cable, yeah, actually, you know, that's a good one. But I need a 3.0 only device. I'll look something up. I have some gear here that we can play with afterwards, and then I can show you how some of those stuff works there. Okay, so USB data distance limitation. So typically at 2.0, you're limited to about 15 feet or so, right? So as speed goes up, right, distance goes down, just like HDMI, right? You go 1080p, you're able to go 15, 20 feet, no problem. Start going 4K with the same cable, your distance is greatly shortened. Okay, so then you would need to look for an extension product. Okay, so we got a couple different extension products. There is some that are inline, right? So then there's an active, basically chip that's going to be regenerating that USB signal. Okay, and then you move on to longer distance, more than 20, 30 feet. You're going to need to go something with a category solution extender, right? So we have a couple of USB 2.0 extenders. We also have the new 3.0 extender that we'll be showing you today. But out there, yeah, I mean, just like what Icron has different USB solutions, but I mean, obviously those are very expensive. If you're talking about USB 3.0 extension, right, it's either fiber, yeah, fiber, right, or category, but I mean, you're looking at what, 1,500 plus? Yeah. Okay. So let's see here. Okay, USB, we talked about the speed already. All right, so like I said, there's a couple of different solutions out there. Active cables are another thing for USB as well. There are some, actually, the longer ones actually have 2 buffer chips in there. And that can actually cause some issues when you're thinking about the logic of how many hubs are in a string to your host. And I'll show you the pyramid of the different tiers that happens when you're doing that. Okay. Make sense so far?
I was going to have a question about when you get to 3.2, those distances with the different protocols you can carry across the cable, but I don't know if you're there yet. So.
Almost there. All right, awesome. So analyzing USB. So here is basically a level pyramid. So we start from the type here, which is going to be our host, right, which is our computer. Our computer also have an actual hub that's built in, right? So my Mac, I'm just gonna think of this as tier 1 because I have 3 different buses for USB, but that's basically considered a tier. Okay, when you start adding more devices to it, you just have to start adding tier counts, right? So with USB 2.0, the standard is basically you can have your main tier, right? And then you can have up to 4 different hubs under those tiers, but that's the max you can do. You can have a max of 7 layers, but only 4 hubs. So 5 hubs total in that entire environment. So here's my laptop. I can add a docking station, right? So there's some USB ports that I can plug peripherals in. Let's just say I needed to extend my USB signal, right? So then I'm going to introduce USB extenders. And depending on the extenders, it's either 1 tier or 2 tiers, because some of them has chips on both sides. So then you have to take those into consideration, that anytime you have any type of peripheral ports, typically that's going to be counted as a hub. Okay. Okay, and then your traditional hub, so your splitter, and then your devices. So as you can see, we haven't even put any switches in this combination of equipment yet. And this is just strictly plugged everything into one. But now when we're talking with AV, right, we have to know how to manage USB switching along with your video. Well, it only gets complicated from there. All right, and the more layers you have, the more latency you have, right? So in this application here, when we're looking at different USB hubs, USB tiers, so on the first one, this hub that has a 4-port, that's one, or a 4-port hub we'll consider as 1 tier. Anything that has 8 hubs or 8 USB ports, it's because they are cascading internally. So then now you got to look at it. It becomes 2 tiers at that point. So if you're taking your computer, plugging in this 8-port or 7-port hub, now you actually have 2 tiers that you already added to the chain. So you're at tier 3, right? Okay, moving on, extenders. Some only has 1, and then some, you notice there's 2 for a longer distance, right? So then those all count as tiers as we come along. Okay, USB over HDBaseT. Okay, so if anytime you see that there's a USB hub port or a device port, like I said, these will consider being hub 1, hub 2. Okay. Same thing, we have an Omega line, which gives us your audio, video, and USB transportation. You still have to count those as 2 because we have ports on both sides. Okay. Any questions? All right, so a couple software that's really cool that I like to take a look at. So one of them is called USB Tree Viewer. And what that does for us is basically you connect, you launch the software, and then it'll break it down for you to see how many tiers you have of certain devices that are connected to your computer, right? And this is a really cool troubleshooting tool that you should have on your laptop, because if you come on site and you're having some issue with an end device and you need to troubleshoot it, once you launch this, you'll be able to see the entire the entire path and where we're really messing up, where we don't see the actual device. And then from there, you could go ahead and go through and count your tiers. So here's a better look at it. So as you see here, here's my laptop, the root hub. Okay, so this is the Lenovo root hub here. Tier 1, Tier 2 is going to be my local hubs within the laptop. So certain laptops actually will have more than one hub built into it. And then as you go, you're starting to add different devices here. So that's just one regular device. This looks like another hub here, right? So USB hub, so that's another 4 port. So now that's considered another tier. These are just other devices that are plugged into this hub. And then you also have your USB 3.0 hubs. So when we're looking in the software, when we launch the software, you'll see that even though the port supports USB 3.0, it also separates the 2.0 devices from it, so you don't get confused. On a Mac, it's a little bit different. There's no software for the Mac, but there is actually a utility within the Mac that actually has this tree view for you, and I'll show you that later on here if you have a Mac.
Did you see the name of that?
This one, yeah, this is called USB Tree Viewer. Yeah. Awesome. Okay. All right, a couple simple solution. I just mentioned the little switcher that we had there. This is actually an MS or MH21, same box, except this one has HDBaseT out. So what we're seeing here is our laptop's connected to this guy here, and then basically that's a hub there. So in here, you'll see that my root hub, and then I got my hub from my switcher, and then these are the 2 devices that are connected to my switcher. Okay. All right. When we're looking at this solution, Okay. Anybody want to take a guess how many tiers we're working with? Not all at once, guys. 7? Okay. 4. All right, we got 4. We got 7. All right. So let's take a look at this guy a little bit. All right, so the switch itself actually has a hub built into itself, right? So that's already tier number 1. Tier 2 is going to be, well, actually, so tier 1's the laptop. Tier 2 is the main switch itself. That has a hub. But tier 3 is actually the USB extender, right? So then you're counting 1 here, that's 2, and then your devices are on tier 4. Okay, so this one's only 2 tiers. Okay, and Tree Viewer kind of shows you. There's other, also, if you go into USB Tree Viewer and actually press on one of the devices, it actually gives you your descriptor of the devices. So sometimes it's kind of cool, like say if you're looking at a camera and you don't know what type of data transfer it does, right? You open this up, this one tells me that this is isochronous, right? So then at least I know that, hey, I need to make sure that when I design the product, or a design, I need to make sure that I have the initial bandwidth for that camera for constant bit rate to go through. Otherwise, I lose enumeration. Okay.
If you guys don't have the software, I strongly suggest you get it.
Yeah, it's free, so yeah. Just look it up on Google and it's free. All right, so the new USB-C connector. So you could be found anywhere, right? Laptops, phones, we all know where everything is. Cool thing about this connector type, it supports your audio, video, right? You also have power capabilities. Nowadays, you could actually have 100 watts up to 240 watts, depending on the device, okay? USB, high-speed USB data, and then also Ethernet can all be in one cable. Okay, so I actually have an example of how we have all this here, minus the power for now, but I'll show you how that all works in a couple minutes here. Okay, so if you're looking at the USB-C connector, you can plug it in either way. There's not a specific direction that you need to plug in, just like our type A or type B. Obviously, the pins are duplicated on the top as it is on the bottom. It's just reverse, right? So when we're looking at the USB-C cable, it doesn't matter. The only thing that matters within there is how many data transfers or how many data channels we're actually utilizing for USB 2 or 3. I know right now it looks really complicated, but I'll guarantee you, this next portion is going to be real easy to do. Okay, so even though this is a USB-C connector, it can be utilized for USB 2.0, 3.0, or obviously your USB 4 and Thunderbolt, right? So depending on the actual cable, so the cable itself, like our charging cables, might not have data, and some of these data pins are gone. But for this one, it's basically a charging cable, and it also has data cables for USB 2.0, which is up to 480 megabits, and only 60 watts of power, right? If it's a USB-C to C. But if you have a USB-C to A, that brings it down to 15 watts because the capabilities of the USB type A, okay? When we're working with USB 2 super speed on each side, you'll be able to get 5 amps of power and also up to 100 watts. Well, actually now it's up to 240 now with the latest devices here. Also, another thing is, how do we carry video through there, right? And that's when we talk about alternative modes. So DisplayPort alternative mode. It utilizes certain pins that changes the characteristics from going to data to video. And I'll show you that. All right, couple of other things here. So when we're working with USB-C, I mentioned earlier, not all cables are the same. Okay, so the longer you go, the thicker the gauge is going to be. This is actually one of our 5-meter cables. This is an active cable, so there is an active chip in the actual cable itself. But that does support basically your entire gamma of your audio, video, all your datas, and it has certain pins like the SBU bus that is used for EDID, what do you call it? Hot plug detect and EDID communication. Okay. Any questions so far? So here's the fun part here. So we're looking at the connector. Okay, your ground's going to be on the outside. These are your data channels right here. You got your data channels on the high-speed end. USB 2.0 only uses these 4 pins right here. Okay, but then these are basically your high-speed pins here. And the CC2, if you're looking at this is the pin that actually, once you connect your USB-C cable to a device, right, and then it looks at it, it's like, hey, what are the 2 devices that we're working with? Are we doing a video? If we are, what it does is it'll take this from a data channel, right, and it'll switch it over to a video channel, just internally, just so that the 2 device knows how to negotiate that, okay? Cool thing about this is now you can have your video, but then you still have your other channels for your USB data, right? But if you end up using something like an 8K, I believe, or higher resolution, those 2 channels might have to be utilized, and then you won't have any bandwidth for USB transfer. So just keep in mind. Okay. Any questions so far? Did that cover? All right. So USB alternative mode. Okay. So I mentioned earlier, not all USB cables are the same. Some will support those pins that are needed for video, and then. I'm just gonna go through it. Okay, so with certain cables, we're able to take from USB-C and actually come out to USB or HDMI, but you can't go the reverse unless there's an active circuit, right? So anytime you see a USB-C to HDMI that's just a passive cable, just know that your computer's able to change the characteristics on the output of that USB to make your HDMI signals, but not vice versa. All right, so let me just bring this up. Okay, so with our switch, we do have a couple of different solutions. This is actually our MS42, and what makes this unit unique is we have the 4 inputs. We got 2 outputs. These are matrixable. So it could be mirrored or matrix. But you'll notice here that we have a host connector here, another host connector here. That's typically is going to be, you can mate it to either the HDMI ports or the display ports for when that input is utilized to switch USB host, right? So the application would be, I have a laptop currently connected to my host 1 and a HDMI 3. Let's just say, for instance, I come in with another laptop and plug in to USB-C. USB-C is actually a host port as well. So technically you have 3, think of it as a KVM with 3 different hosts that you can switch between your peripherals, right? How we do it in the circuit that we're looking at here is we switch based on the last active host, but systematically through a control system, you can actually turn that off and assign, when you're switching, which port you want to be active, right? So by default, whatever the last host and video signal that we see, well, that's going to be our switch based on the logic on that. Okay, and then on the back end, we're just using the webcam as an example. This guy is currently connected to this webcam. You come in here. This webcam now gets switched over to the last host that's active. Once you disconnect that USB-C cable, it still sees the host on the other end. It'll actually reconnect it. So in an application where we have an in-room PC, that's perfect for that. I come in as a guest, plug in my laptop. I'll be able to use the peripherals within the room, disconnect, walk away. Everything's back to normal without anybody's, interfacing with a control system.
Is that one actually charging too?
I'm sorry?
Is that one charging?
This one?
The USB-C.
Oh, yes. So this specific unit, yes, this does supply 60 watts of power on the USB-C. Yeah, USB-C and data. Yeah. So this one specifically is going to be audio, video, data, and power. Any questions? All right. All right. So other devices that we typically run into, audio is going to be our DSP. You know, it could be our little puck for like analog audio and speakerphone combos. USB data is going to be your cameras. You know, those are your typical ones. Ethernet adapters. So I have a little one right here. These are obviously used quite a bit for applications where, you know, I don't have enough real estate for Ethernet port and I need to connect to it. That's going to be plugged into a hub as well. And then power essentials, right? So delivery of power. Thought that bird was just coming in.
Yeah, I
was like, whoa. Okay, so we already know that all the new peripherals are going to USB-C. Okay, so this is actually really important here. So on certain devices, I remember when USB-C first started getting adopted for laptops, the thinner ones, you'll see there's 2 USB-C ports, right? And based on that, this might be just for power only. Or it'll tell you, okay, this is for video, but some of them doesn't give you anything. And you plug in and you're like, hey, I'm not getting video. Well, at that point, it's either the laptop doesn't support it yet. So I had actually an HP that did that. I called them like, well, it's not implemented yet. Okay, well, thank you for letting us know. And then the other thing is it's going to be our USB-C cable. And that's, I found out the hard way. Plug this in. I've been testing with all of our new products. When I had them in Mac, I'm like, we have some issues here, guys. Like, what are you talking about? It works. I'm like, no, it doesn't. I wish I had this little cool tester when that was happening, but I'll show you a couple of cool things with that. Okay.
got a question for you.
Yes, sir.
On that HP issue you just mentioned.
Yes.
Is that a hardware, like a pin configuration, is that USB, or is
It depends if they, yes, so there's 2 of them. It's either they didn't implement it in software yet, or it could be a hardware where the pins aren't supported yet, or aren't supported. So it would have to be a hardware change if it is. But the one that I was working with, they haven't implemented that in the software yet.
so in future releases may be?
Correct.
Okay.
Correct. Yeah, but that was probably 7 years ago.
Oh, okay.
Yes. Now everything should be all good. Yeah.
I have a question for y'all. Are you guys seeing more USB-C being used? I mean, for us, since we're now supporting higher bandwidths and we know what we do, a lot of the higher ed stuff that will flip from competitors is because they can get now USB transport to and from. It's 2.0 right now, but with our new products, now they're going to get the full 3.2 or 3.0 category. Are you seeing more use for USB-C in the classroom spaces? Is it becoming teachers only have USB-C they want to plug into, or is it still a 2-cable solution? Where are you?
Yeah, so this is one of the strong reasons why I'm here, because we're thinking about, not thinking about, it's in our roadmap coming up to implement USB-C as a connector.
Yeah.
And where it came from is, obviously, Apple users.
Sure.
People who had MacBook Airs would come in and say, oh, well, your system doesn't support my laptop because there's no USB-C.
Yeah.
And, you know, this is however many years ago, and now you can't even get a device almost with an HDMI on it. So, you know, we made that decision a little while ago that we have to go to USB-C as a connection standard. So that's kind of where we are now, where we're not there yet. People still have HDMIs on their devices, but it's getting to a point, my laptop right here, you know, it's getting to a point
Right.
where devices are only gonna come with USB-Cs. And how do you meet that challenge in the classroom? Now, luckily, in my context, we had already kind of foresaw this, or we looked at things a little differently when we saw connectors starting to change, because we got away from like octopus connectors, so to speak, and we went straight to Mercer Solstice. So that's one of our standards, wireless connectivity, but we still need to support the hardwire of the device.
Right.
So,
Right. Right. Perfect. Perfect.
My experience was a little different. I was working at the University of Houston, and the network team started utilizing USB-C as patch cables, and I looked.
Patch cable.
For what? For what? On the network, in the IDF closet, they use USB to USB-C, and when I saw that, that now that the I started investigating, Cat 6.
Some sort of extended file.
I haven't heard that, or I haven't seen it. Yeah.
They have
So
pictures of this?
yeah.
No, they
Wait.
have-
So are you saying that in the IDF they're using USB-C like C-to-C cables to patch network, or
C2C.
yeah, right? But is it to patch network, or is it something else?
It could have been something else. I just
Okay.
saw that they had it in the.
Yeah.
closet.
Yeah, I wouldn't think that would be the case because, I mean, in an IDF, I mean, that can easily get unplugged real quick.
Well, that's my other issue with USB-C and some of these other connectors. You know, as much as I hated some of the connectors, they had a way to.
We got to.
Yeah, I wasn't gonna say the bad word VGA, but you could take those two pins and screw it in and feel comfortable that it was connected.
Yeah,
But with HDMI and USB-C,
right.
will that thing connect? And then going back to the classroom, when you do use like some USB connectors,
Mhm.
and I see this even on docking stations,
Right.
on computers, is that
Right.
they move it around and they pull that cable out.
Absolutely.
enough, and after a while, the USB-C on the device, it widens a little bit, and that
Mhm.
cable doesn't fit in there as snug.
Right. Yeah, I mean, I would design it in a way where, obviously, if it's going to be something that's going to be highly, I guess, utilized with inputs and outputs, I mean, USB-C, you can't really have any type of barrel connector because most of them don't follow the specs for all the data flow through. We were trying. I can't remember what project we were working on, where everyone was like, well, to not damage the actual devices that we're implementing, we're going to put in a barrel connector. I'm like, no, it's not going to work for you. But yeah, I haven't seen so much issues other than the quick disconnect. But if you're working with like a commercial appliance or whatnot, typically you'll have some type of screw on, just similar to what we have. We implement any type of screws with USB-C so it doesn't fall out, at least on the equipment end. Okay. All right. Let's talk about hubs. So USB-C hubs. Okay. So I already talked about hubs on our computer being able to do video, right? But when you're buying an aftermarket hub to get more USB-C ports, chances are video is going to be unlikely because this doesn't know how to negotiate those pins. Remember I was telling you? It negotiates and then it switches the data for video versus the high-speed data, okay? Audio, yeah, most likely all the rest of your USB data will be passing through, but just keep in mind, if you're trying to do video, it's not going to work. Okay. As far as power devices, you know, we've all went to Amazon, look at like Anchor, you know, blocks. Some of them say, hey, you know what? We can do 60 watts of power, but is that 60 watts per port, or is it gang together? Or did you have to add another device like a power injector to get your power? So all that, you got to make sure you got to research and design it accordingly to your needs, right? Okay, so USB inside of an AV system. So what we're looking here is how we actually transport our audio, video, and controls through a switcher. So our Omega line actually has anything from a 2 input to a 6 input by 2 output form factor that basically will support your audio, video, and USB. This is the MH21 that I mentioned earlier, very similar to that unit over there. But then you have your 2 USB-C and HDMI ports that will be able to negotiate any type of USB devices there and switch accordingly based on the active video. Okay. Okay, we already talked about that. You notice that little screw there for your needs? We got you covered there. Yes, these are all auto switch. So if you're looking at any device that actually has a LAN port there, on top of the auto switching, that's for your configuration. We actually support some control, I guess, capability, basic control capabilities. So a display, you can come in, just plug in your USB-C cable or HDMI. We'll recognize that there's something connected. We'll actually send out an RS-232 IP or CEC command. You could choose whichever flavor you want to the display to turn on and off. And you could set the delay for, like, say, if nothing's plugged in for 10, 15 minutes to shut off the display. So that's one way to kind of save on automation. And it's more plug and play rather than having somebody having to go look for a wall panel somewhere to turn on your system, okay? Okay, let's see. We talked about the host ports already. Okay, this just kind of shows us. I'm going to skip through this because it's kind of repetitive. Let's see. Cool. Any other questions so far? No? Yes.
I did have a question.
Yes.
I don't know if, go ahead with this, because this might be some of the things I have with,
Oh, this is just my ending slide. It's like, hey, it's more important than ever to understand how USB works and how you integrate that with AV.
So I saw you had the slide about USB alt, and my question.
USB
You said USB-C alt you had, or
alternative mode?
yeah, alternative mode.
Yeah.
So my question kind of is, as I try to understand these things, preemptive of the users asking, is
Right.
how is it different on the cable between this USB-C alt?
How it supports it?
Well,
Like
how does it read the protocols different from like that and like DisplayPort alt and Thunderbolt 3 and Thunderbolt 4? Like, how does all that? How does something support like DisplayPort alt but not Thunderbolt 4? Like those kinds of things.
it's all based on the cable.
It's all based on the
Yep,
cable.
on the cable. So perfect. Let's actually have some fun with USB here.
So it's funny you say that, because that's one of the things that I really fear as this rolls out to the end user.
Right.
That oh well, the cable works in this, and it's like yeah, but
Yep.
it scares me a little.
All right, cool. So let me. All right, let's do some fun stuff here.
So I just bought a cable from Extron that worked on everything, but it did not work on our MacBooks. So they said it should, but then when they started looking at the cables, they said because it only had 4 lanes,
Yes.
it wouldn't work. So they sent us an 8-lane cable, and that worked. So yeah, there's challenges.
All right, so let's do something fun here. Okay, so. All right, so this is actually my little handy dandy cable tester. It's a USB cable tester.
Where can I get that?
Yeah. You want to take it? Yeah. I'll actually go ahead. Yeah. We're gonna get it. All right, there you go, cool. So let me maximize that real quick. Okay, so let's see. Bring that up a little bit. Cool. All right, so let's talk about some cables. Okay, so this is our typical cable that comes with our MacBook, right? Okay, so let's go ahead and plug this in real quick. Okay, so I have that plugged in. Now I turn this on. Okay, so now this cable actually tells me that, hey, look, this is actually a 2.0 cable, right? So the transmission on this, it does do power transmission, right? So that's how you're getting all your like, say, 87 watts from the power supply, whatnot. But as we go through and take a look at this, so if you're looking at the pinouts here, there are some pins that you see that are in red, right? So on the pins that are in red, TX2 on the left side and RX1, those are your missing pins for your high-speed data, right? Okay, so as we go through, oops, where was it? This guy go to sleep or what? Okay. If you take a look at not the VBus, the SBU, there's a pin that says SBU. That's called sideband utilization. And that one basically is the pin that does your hot plug for video and your EDIT information, okay? So, you guys take a snapshot of that already?
Yeah.
Okay. No, that's fine. And then if you're looking here, this is the E marker. So it's basically a embedded chip in the cable that tells you what the capability is of that cable, right? So this one tells me that, hey, this is a less than a 2-meter cable, right? But then it supports up to 480 megabits for data transfer, okay? So, all right, so you see that. I'm gonna go ahead and take a look at, actually, is the other cable around?
Jason.
I got a question for you guys. Don't you think there should have been a keynote speech?
It's pretty cool. Yeah, it's extremely,
I think more people have been like, we'll realize that in another year or two.
right.
And we'll be like, no.
But that's what I'm saying. This is like, to me, was like, this should have been a keynote. Because people don't understand half of this, and when they go,
Yeah.
this, they go. This is very forward thinking.
So, so think of yourself as ahead of the curve when you're at a conference next year.
No, that's exactly why I'm attending, because I'm like, I need to know in a couple years, because we need to start phasing out HDMI eventually.
We have, the reason why I asked the question is obviously the enterprise, Amazon's a big customer for us, they're a golden user of ours, as is Microsoft, and they actually probably code actually on that box I showed you, the SW21TX, because Mr. Bezos, but number one or number two in the company, like, I'm tired of these dongles, get this shit out of here, so my friend, I want one of these.
Is that the one that's not available yet?
Yeah, so the box is, the firmware is not quite done.
Okay.
It's almost done. And then the extender 3.0 product, which Donald will show you functioning while it's out in the booth, they could literally now get rid of any and all matrix switches in their classrooms. They can run everything over our extender kits. We can use SupplyLink to handle all the video, and they can also have pass Ethernet with an adapter that Donald's going to show. We have it running in the booth. They basically run almost 90% of their conference rooms on that device. And they'll call 3.3.3.0 capabilities, one USB-C cable, and also our new USB 3.0 products are also networkable, so that they have a full UI. So they could assign an IP address to each one of those devices, and they'll know instantaneously when it's down, why it's down. I mean, it's what we're going to show you pretty badass. But the reason why Amazon was so interested in that box, they can still have HDMI coming into it, but it's got the 3.0 transport capabilities with an extender. So if they have to have the 3.0 products, they can set up USB-C cable coming in, which is a full host cable, also 60 watts of power. That's a one cable solution, and they can just extend, from the switch out to the device out to whatever purpose they want, and now they have it in the conference room, and they can also monitor those rooms remotely. And it cuts down the integration speed. I mean, they could literally build a room probably in about 15 to 20 minutes. Jeez. Right? It's literally just, once those IP addresses are assigned, plug them into the network, plug the cables in, connect their laptop to make sure we can test it out right, and they're up and functioning. So, I mean, this is really cool stuff.
Yeah.
And our future product sets are all going to be going in this direction. So,
All right. Okay, so as you see on this USB-C cable that I have, obviously you see that there's a 3.2 that's enabled. Okay, if we're taking a look at the pins, see how many pins are connected on this cable? So that's the most important part is if all the pins are actually there, you'll be able to do a lot with this cable. You'll be able to get your alt mode, and as you're looking there, the SBU pin is enabled there. So I can guarantee you, I can plug this into my little monitor over there for my laptop, and automatically get video and power to the actual display itself.
So, do you know who manufactured that cable?
Yeah.
Is it just
Yeah.
Really good.
What's
Oh, it has a lot from it.
B657?
Please.
So
Thank you.
B657 is basically just opposite. So
Yeah.
So when you
yeah, it'll switch to the other side.
okay, so everything else aligns every time you
Correct.
connect it.
Correct. Okay, cool. And then let's see. Lastly, okay, and the last part is this cable is capable of 5 gig. So, okay. All right, cool. So that's, I mean, this is just the cable tester. Man, I need to reach out to.
Yeah, you should be accused.
No, I'm like, hey, look, you know how many of these you bought? No, I'm just kidding. All right, cool. So why don't you guys come up here? I'll kind of show you a couple of cool things that we have going on over here.